2x squared minus 3x minus 4 so equals to 0. So off the bat, we already know what we have to do. We have to know their leading coefficients so that they're plugged back into the quadratic formula. So I already know that A is equal to 2 because the number next to x squared is 2. B is equal to negative 3 because the number next to x is negative 3. And C is equal to negative 4 because it's just constant. So now all we have to do is plug it back into our formula. What is B? B is negative 3 plus or minus the square root b squared, so negative 3 squared minus 4 times 2, and then C, which is negative 4. C is equal to negative 4. All over 2 times 2. So now we just have to simplify it. So negative times negative, it would give us a positive 3 plus or minus 3, negative 3 squared, which is just 9. So negative 4 times 2, that's negative 8. Negative 8 times negative 4, that is positive 32. All over 2 times 2, which is 4. So now we just have to continue and simplify this even further. So let me just erase this part. We have 3 plus or minus radical 9 plus 32 over 4. 32 plus 9, that would give us 41. So 3 plus or minus 41 over 4. So as we said previously on the last example, we're going to try to focus on this radical. As we can see that there is not really a number that we can multiply and you can get a common number from it. So we would have to just leave the radical the way it is. But we still can simplify it. So in turn, this just means 3 over 4 plus radical 41 over 4 and 3 over 4 minus radical 41 over 4. So in turn, this could be written as our final answer. The answer could be 3 over 4 plus radical 41 over 4 is equal to x, or 3 over 4 minus radical 41 divided by 4. So let's always keep that in mind, that this radical can always be simplified, but in this case it can't. So now let's move on to number 4. Number 4 states negative 2x squared plus 5x is equal to 6. This problem looks very similar to both 2 and 3 because we have leading coefficients that are not 1, and we also have the right-hand side not equal to 0. So let's use the similar technique we used in number 2 and apply it to number 4. So negative 2x squared plus 5x is equal to 6. So in order to get 0, we have to subtract 6 from this side and move it over to that side. So minus 6 minus 6. And what we get is 6 minus 6, that becomes 0. And negative 2x squared plus 5x minus 6 is equal to 0. So this is already preparing us to use the quadratic formula. So now that we have this one, we have to find our a's and our b's and our c's. A would be equal to negative 2 because it is the number next to x squared is negative 2. B would be equal to positive 5 because the number next to 5, or the leading coefficient next to x, is 5. And C would just be negative 6 because negative 6 is a constant. It's a constant number with no variable next to it. So now we have our numbers so that we're able to plug them in to our formula, which is very simple. So it would be negative 5, because B is 5, plus or minus the square root of B squared, so that becomes 5 squared, minus 4 times A is negative 2, and times C is negative 6. All over 2 times negative 2. Negative 5, negative times a positive becomes a negative, plus or minus 5 squared, that was just 25. Negative 4 times negative 2, that's positive 8. Positive 8 times negative 6, that's negative 48. All over 2, negative 2. So now we take a look at this radical, and we see something very different than the other radicals. 25 minus 48, that would actually give us a negative radical. So from the basis of just seeing these two numbers, knowingly that they're going to give us a negative number, we can already know that this has no real number solution. So the problem is already solved. And we can write no real number solution. Because the numbers inside the radical will be equivalent to a negative number. And from that basis, we can write this, and that would be our answer. So now we're on problem number 5. Our problem number 5 is pretty self-explanatory. It's 3x squared minus x plus 1 is equal to 0. So off the bat, we already know we have to find our leading coefficients, which are a, b, and c. Using this concept, we'll figure out what our a, b, and c are. So the number next to x squared is 3, so a will be 3. So for this one, you don't see any number, and the rule before was that when you don't see a number and x is in front of it, this automatically becomes a 1, so it's negative 1 because there's a minus sign in front of it. So b is negative 1. And c is a constant because it's already given, and that's positive 1. So now all we have to do is plug it into our quadratic to see what we can get. So it's negative b plus or minus b squared minus 4ac all over 2a. So it's negative 1, which is our b, plus or minus the square root of b squared. Our b is negative 1. We enclose that in parentheses, put the squared, minus 4. Our a is 3, so we multiply it by 3. And our c is 1, so we multiply it by 1. All over 2, and we multiply that by 3, which is a. So off the bat, a negative times a negative is a positive, so that gives us positive 1. Plus or minus the square root of negative 1 squared, which is just 1. Negative 4 times 3 is negative 12. Negative 12 times 1 is 12. So negative 12 times 1 is negative 12. So that would give us 12. And then 2 times 3 is self-explanatory. It gives us 6. So in question number 4, we had the same issue. We had a negative. This radical would give us a negative number. But there is another way to solve this problem by using an imaginary number quadratic formula, which can solve this little issue that we have here. So the imaginary number quadratic formula in order to solve this issue, because we don't want to solve for no real number solution, we actually want to have a solution, would be negative b plus or minus 4ac minus b squared times I, all over 2a. And we can refer this to as imaginary number solution. So now let's try to plug in these coefficients in, but try to plug it in to this formula, because we see that 1 minus 12 gives us a negative, so we want to get a solution. So let's erase this and plug it in to this formula. So off the bat, we know negative 1, because it's b, plus or minus 4a. I forgot to include the c, so remember, it's 4 times a times c. This is pretty much flipped around, but we're adding an I. So 4 times a, which is 3, minus b squared, so minus 1 squared, times I. I is outside the square root, over 2 times 3. So what we know, negative times a negative, positive 1, plus or minus 4 times 3 is 12. 12 minus positive 1, because negative 1 squared is positive 1. So that just becomes 12 minus 1 times I over 6. So now this is positive. So all we have to do is solve. 1 plus or minus radical 11 times I over 6. So as we said earlier, we always try to simplify this radical, but this radical cannot be further simplified. So our solution would just stay this way. So in terms, this just means 1 over 6 plus radical 11 times I over 6, or 1 over 6 minus radical 11 times I over 6. In simpler terms, you could just add the x, and this would be the imaginary number solution if you were trying to find it this way. Thank you.